triangle has just got a lot of stuff on it. So it's got sides like this. And angles like this here. So I mean, when you first look at this thing, you're a little worried about what they're going to ask you to do with it, because it's a little large in just how much information they're throwing at you. If you have your book, you might want to look at that. This is a little bit claustrophobic up here, but Part A says write the perimeter. Write a polynomial that would represent the perimeter of this triangle. And we haven't really talked too much about perimeters, but you never need to memorize any perimeter formulas. What's the idea of perimeter? How do you get the perimeter of anything? Add up all the sides. So Part A is nice, right? And actually, so is Part B. But Part A, how do I then get the perimeter of this triangle? What are the things that I need to add together? Yeah, all the side measures, right? 2y minus 3t. What else? 5y plus 3t. And then 16y and 5t. So now we're down to that whole, exactly, cool, like terms, right? And I don't know how many guys like the method that I use. Personally, I just use different underlinings. What all can I put together? All the y's and all the t's. So how many y's do I end up with? 2 and 5, 7, and 16, 23. And here I got negative 3t plus 3t, 0 so far, plus 5t. That was definitely nice.
Yeah, I got that.
Sweet. Now Part B. Okay, so I'm going to make sure everybody's got Part A. Part A is pretty straightforward. Just add all the sides up. Part B says the degree measures of the angles of the triangle. Now this actually goes back to an earlier section when they gave us, like, I don't know if you guys remember, they gave us angles that kind of made a straight line. And of course, what do those angles have to do if they make a straight line? So if I have two angles like this, yeah, exactly. These two angles, if this is x and this is y, x plus y equals 180 degrees, right? 180 is what they call a straight angle, believe it or not. So that's 180. So I have the same really idea here. I mean, what do all the angles in a triangle have to add up to be? 180 also, right? So then how would you set up that equation? All right, 2x minus 1 plus 7x minus 3 plus 5x plus 2 has to be 180. I remember that the test we had, a few of you guys made a mistake of setting it equal to 0, because it seems like when in doubt, we set it equal to 0. But then you get these weird negative angle measures. This is much better. We get that equal to 180. And that's actually now back to chapter 2. That's nice. Right? How do I solve that equation? Beautiful, right? So that's the connection they're trying to make. We've already done like terms before. We just never called them polynomials before. So 2x, I like it. So I get 9x plus 5 is 14x's. Good. Minus 4 plus 2 is negative 2. Add 2. So this is nice. I mean, this part. Don't forget, as you're working new sections, they're going to have problems that go back to old stuff, of course, because it's not old. It's just that it's useful tools. And this is another place where we could hit solving equations. And then how do I finish that out? Divide by 14. I like it. 13 what? And what does that really mean? Now be careful now. What are all the angles? They're asking me what are the angle measures. So are any of my angles 13 degrees?
One of them is.
Are you sure about it? Look at your angles. So I like the way you're thinking, Wes, because when we set up a word problem, we always have something that's x, right?
Yeah.
Well, we weren't there when they set this one up. So somebody did something different. Where it's like, oh, it's too bad for us. If x is 13, how do I figure out this angle? Plug in 13, yeah, cool. So now I can just take each angle at a time, plug in 13. So for example, this one. So twice 13 minus 1. Yeah, 26 minus 1. So you get 25 degrees. Keep going. All right, and so you can do this one and this one. You can finish that problem out. How do you check yourself at the end? Add them up and see if they're 180 still. If they're not, something went a little free. How's that? Say? Yeah.
When you put them together as a 2y plus 3, or I mean, like, if you set them up, does it have to be a certain order?
Oh, like why did I put 2x minus 1 first or something? No. That's just the first one I heard somebody say. Okay. All we got to do is add these up. And what is it about addition? I can add whatever order I want to. So yeah, it'll still come out to be 14x's and minus 2. Any other questions from homework? Yeah.
How many get the 5t?
Here?
Yeah.
So the negative 3t plus 3t cancels, plus 5t. Yeah. Cool.
So will the answer be 13 or 3?
So you gotta be careful. That 13 is the weird part. When we're just solving equations, we're so used to stopping at x equals 13. That actually has nothing directly to do with any of my answers. It's a part of each of my answers, right? They want my angle measures. Well, this angle is 2x minus 1. I got to throw 13 in there. I've got to throw 13 in there, and I got to throw 13 in there. So my three answers, none of them will be 13, but they all involve 13. Yeah. Cool.
Okay, so on part A is 23y plus 5t. That's what you got, right?
Yeah.
Now that's just the answer. You can't combine those two, not.
Yeah, what's different with part B? Why am I able to solve that one? Because I know no matter what kind of triangle I got, all the angles have to make 180. But there's nothing about the side. The sides can be as big as they want to be. The sides don't have to add up to be a certain number.
Yeah, it just doesn't seem like that should be an answer. That's more like an equation.
And it is, you're right. Because once somebody tells me what y and t are, I can tell them what the perimeter is. So we have to get away from, this feels a little bit of a letdown to us because we want to get a number, and I don't blame you. I want to get a number too, but we just don't know what the hell y and t are. If they told me, even if they told me that the perimeter of this is 30, I could set this equal to 30, could I solve it then? Could I solve that? What's wrong with this? Why couldn't I solve that then? How many things do I not know? I have two things I don't know. How many equations do I need if I have two variables? Two things I don't know. I need two equations. I love it. I would only have one anyway, so I'm actually okay with that being the end, because then I've got no more work to do after that.
No equal sign.
No equal sign, because I don't know what it is. Yeah. Whereas part B, I know it's 180. It's got to be 180.
And when you add up all the angles inside, that's equal 180.
Exactly. I don't care how big your triangle gets, it's still 180.
Now, if you look at number 80, it's the same. Is that the same way you set it up with the perimeter?
Exactly. The thing they're trying to make you, they're not trying to make it tricky necessarily, but don't forget there's two of each of those sides, right? So you have to do y plus 4 plus 5y squared plus another y plus 4 plus another 5y squared, so forth, right?
Okay.
To get the perimeter of a rectangle, you have to go all the way around.
Yeah.
So if I just tell you that this is y and this is 2y, is the perimeter 3y? Isn't this side, well, this doesn't really make sense from what I've done, but oh. Wouldn't this be y and this be 2y? So to get the perimeter, don't have to go, so just fill in the other two sides and then add them all up. That's the awesome thing about perimeter. You don't have to memorize any perimeter formulas because it's just the idea of add all the sides up. Areas are harder. You got to know the area formulas to do it. But perimeter, you don't have to know any formula. Cool. Any other questions from? Okay. All right. So what we're gonna do is we're gonna finish up 5-6. Right. Some of you guys might not realize we actually did get into 5-6 last time. 5-6 is really nothing new. It's just kind of special little multiplications that we can do. Yeah.
On section 5.5, question number 70.
70?
Yeah.
Oh, okay. Yeah. That's sort of going back to. This will be the last one I do here. And they say this is what shape is this?
It's a square.
I like it, Justin. Yeah, it's a square. And you gotta let them tell you that because you can't go based off of what you think. It's a rectangle otherwise. But they tell me it's a square. And they seem to have not told me much information at all. So how in the world will I get the perimeter of this if they only told me one side? Well, in a square, all the sides are equal. So the first thing I would do is if that side's 6x plus 2, then that's 6x plus 2. And that's 6x plus 2. And that's 6x plus 2. Yeah. So how'd you get the perimeter there? Add them all up like we just said a minute ago, right? And how'd you get the area? What's the area of a rectangle? Length times width. I like it. Yeah, just what's the length? 6x plus 2. And what's the width?
6x.
All right, so you just got to multiply those. Cool. You don't have to multiply all four sides. We know we don't have to do that. Area just takes the length times the width. Cool.
But if you actually solve it, wouldn't be a thing to make it actually just do combine, right?
Exactly. You're going to end up with an expression because, again, I don't know how big the square really is. I know that if somebody tells me what x is, I know how to find the
I
side.
got
Yeah.
an expression essentially.
Oh, yeah, you should get an expression. Yes?
How do you know all of them are 6x plus 2?
Because it's a square. And a square is defined to be a special rectangle, the rectangle where all the sides are the same length.
Also, you can kind of get like 90 degrees.
It's 90 degrees, but it still just means it could be a rectangle. Yeah. All right. Cool. Okay, so let's get back into 5, 6. And let me actually just ask you guys directly. What do you think about? Let me build us up to this. I know a couple of us weren't here last time. How do I do that?
We're just gonna times x to the x and x to the.
I like it.
Figure.
Foil, I like it, right? Foil was the mnemonic device you guys learned before. First, outer, inner, last. I told you last time, if you didn't learn it, I actually am kind of a little happy about that because you really don't need it. It's not very useful because once you put some more stuff into one of them, foil goes out the door. Because this is going to be more than 4 things. The idea here is I take the x, and like you said, what do I do with that x? I've got to
Tax it to the x.
distribute it.
Minus
Because now I've got 1, 2 things to distribute through. So what do you get when you distribute that x through?
x cubed.
Square.
X squared
Minus 3x.
minus 3x. Now you got to take the 2. He's got to get his turn, right?
2x.
2x
Minus 6. Negative 6.
minus 6. And then you look to see if you have like terms. In this case, I do. So I get x squared. Good. Minus 1x minus 6. I love it. Sweet. Quick little side note on this, and I'm going to do this when we get into factoring also. I like to make this a little more concrete for people. I mean, what the hell is x plus 2? And you got to love when the math teacher asks that kind of question. Like, I don't know what the hell he wants from me. It's a freaking letter and a number. But what, can anybody tell me, what is x plus 2?
Isn't there a naturally 1 by the x?
Sure.
Those two. It's just x.
A number.
It's some number plus 2. So in general, x plus 2 is some number. Why do I don't know what it is yet because nobody's told me what x is yet, right? You guys kind of with me? That's the whole point of x's. They're just numbers I don't know yet. So this problem is done. I'm about to do my own stuff here on the side. So you never have to do this yourself. Everybody understand? If x, somebody give me a number. If x was what?
3. 2.
5.
Let's say 5.
6.
I like 5. Let's say if x is 5. And we're just kind of exploring this, right? Because x can be anything. So let me make it something. What the hell? X can be anything. I'm going to make it something. What is this then? What's x plus 2 and what's x minus 3? What's x plus 2 going to be if x is 5?
5 plus
5 plus 2? 7. 5 minus 3? 2. And what is 7 times 2?
14.
Now, when we do this, what are we saying is true about this and this? They better be the same damn thing, right? Or else we screwed something up. So if x is 5 and I get 14 when I look at this, what do I better get here if I plug a 5 in?
14.
I better get 14 because I just claimed that this times this is this. Right? So it better work for any x. So if x is 5, what do I get here? What's 5 squared? 25. Minus 5. Minus 6. 20 minus 6. 14. Kick ass. Right? You can see that? That's the concrete thing behind what we're doing. When we multiply these two things, you're actually multiplying an infinite number of numbers. Because what could x be? Any damn thing I want. It could be 7.8. I don't want to do that, but it could be. Right? Oh, no, so far. So, just to make sure you understand, you never have to do this. Right? And most business teams are pretty good with foiling things out. That's what this part here is. What do you think then is going to happen if I do this?
It's gonna be.
I'll tell you what it definitely isn't. What do you think the biggest mistake is that somebody would make here?
They're gonna make 3x.
The mistake that somebody would do is they would say x cubed plus 2 cubed is 8. Now does anybody see why that's wrong?
Yeah, you should get out too.
Yeah. Exponents are based on what operation? What are exponents based on? What does 3 cubed mean? Yeah, it's multiplication, right? It doesn't play well with addition. It can't distribute across that. What does something cubed really mean? Like if I asked you, figure out what 9 cubed is, what would you do in your calculator? 9 times 9 times 9. So what is x plus 2 cubed? X plus 2.
X plus.
And see how this is just way wishful thinking? I don't blame this person a lot for hoping it's this. It was quick, but it was wrong. So you quickly got the wrong answer. It's no good. So whenever you have something like this to a power, you've got to actually do what the power says. Write it that many times. Now, how the hell do you do this? The next big mistake I see is somebody tries to do all this at once. Good God. How do you do, for example, little side note, how would you do 6 times 7 times 5? What would you do? Okay, so you would first do these, and then 42 times 5, right? Cool. So what do you think I could do here then? The same thing. Because these are just numbers I don't know yet. They better act the same as any other number does. Because that's what they are. What's x plus 2 times x plus 2? Good. X squared. 2x. Plus 2x. Plus 4. I like it. And what do I still have that I haven't done yet? The other x plus 2. Am I done with this? What can I still do with this here? Good. X squared plus 4x. And then here, you guys finish it out. You do the next step. Well, some people are like, damn, I should have been writing that down. Well, in this case, FOIL doesn't work, you see, because there's more than FOIL. There's like FOIL, because there's middle and last and middle and first. Screw the FOIL in. Just distribute that guy, distribute that guy, distribute that guy. That idea works. I don't care how long I make either one of them. That idea works.
Now you want us to do that?
Yes, finish it out. Do the last step there. It's multiplication though, right? So you have to distribute each of these one at a time. Just like we did up here, really. There's just more stuff here to distribute.
So this isn't for FOIL, then this is FOIL.
This is like FOIL's older brother. When I get to it, right? There's more to it.
So we distribute the x squared into the x into.
Exactly. So we put it up here.
This is all it's like 5.6.
5.6, yeah. So I know some of you guys are a little possibly confused because we've done one with 3 and 2, but it was actually the other way around. But I desperately want to show you how you always know exactly what to do. How many things do I have to distribute? 3. So do this one first. What do you get here?
X3.
X cubed, good. X, 2 of them times 1 of them, that's 3 of them now. Good. X squared times 2.
2x squared
2x squared.
plus
Now do this guy.
plus 4x. 4x squared
4x squared.
plus 8x
Good. Plus 8x.
plus 4x
Cool. And then this last guy.
plus 4x
4x
plus 8.
plus 8. Do you guys see that? Do you guys see how I would understand if you would be upset if I gave you one that had 5 things in it and 7 things in it?
Yeah.
But do you realize how that would just be a long problem, not a hard problem, right? Because you just have to take each of the 5 things and give them their own turn to distribute. Who cares? It's long, but not hard. And this is really nice, actually, because where are all the like terms? They're right next to each other, aren't they? What are you here?
6x squared
And here? Cool. That's it. Because I have no like terms I can put together anymore, right? No more x cubes, no more x squared, so forth. Yeah. Cool. Okay. So that's not too bad. So you can imagine, I mean, I'm not going to do x plus 2 to the 8th power. But what would that mean if I did x plus 2 to the 8th power, just to be incredibly evil? What would you do to start x plus 2 to the 8th power?
Do it 8 times.
Write it 8 times. Do the first 2. And then maybe do that one with the next one, do that with the next one, do that with the next one. I mean, that would be
Oh, sorry.
evil. But at least you know how to set it up. Yeah.
So I messed up a little bit on this. Where it says 4x times that you distributed.
Yeah.
I put 5x to 4x squared.
Oh.
That's-
Coefficients are based on what operation? Now this is where you gotta be careful because I'll have people tell me multiplication, but what is 4x? 4x is doing what? What's that mean?
4 times x.
Well, it means 4 times x, but 4x is doing what?
4 times number.
Coefficients are based on addition, right?
Yeah.
They will only change when I add more of that thing to it. Exponents are based on multiplication. So if I have 4x times another x, now I have 4x squared. Now I have 2 x's, right? X times x is x squared. So be real careful. That doesn't become 5x. I'm not adding those together. I'm multiplying those together. So exponents should change when I multiply. Cool. All right. Maybe. Here, you guys try this one, and then we'll move on to some new stuff. Make sure everybody's on the right track. What is it that you have to do first thing?
X minus 3 times 2.
Well, twice, right?
Twice,
Write it
yeah.
twice. Cool, I got you.
Yeah.
You can't do x times x and negative 3 times, you can't start distributing because order operation says you must do exponents before you multiply. Like, you don't want to hear Alright, so hopefully you guys wrote that out twice first. Good.
So, do you have to start off with 2x?
You don't have to.
Do we do x minus 3 before we get x?
Definitely. Just like that earlier thing I had up there, like 6 times 7 times 5, whatever I had. Of course you can do the 6 times 5 and then times 7. That's easier because 6 times 5 is a nice whole number, 30. Right? You can multiply whatever order you want to. When in doubt, though, just go straight.
I think I made a mistake too.
So what do you guys get here?
X cubed.
Careful. X squared.
X squared, yeah. Minus 3.
I think I made a mistake.
Minus 3. Plus 9.
Cool. And what's still over there?
X plus 9.
Because I haven't done anything with that yet. What can you do in here still? And now that looks a lot like that step we had over there, right? I just have 3 things to distribute. And distribution, allow it to be easy. Distribution should be one of the, oh, thank God, and let everything be this. You just have to be careful about when you multiply, x times x, you get x squared. Not, you got to be careful with that. Well, what do you get here?
X cubed.
9x squared, I like it. Now this guy gets his turn, right? Minus 6x squared. Beautiful, minus 54x. And this guy gets his turn. Plus 9x. Plus 81. You can see why it's not called FOIL, because there's more than 4 things I'm doing, so it kind of runs out of usefulness.
If I don't do this step, that like no, the one before, I didn't make it minus 6x. I just kept it like this, like that.
Oh, like this?
No, and I did it.
And then you distributed all 4 of these.
Yeah.
You'll end up in the same place. You just added one more step you didn't really need, but you'll still get the same answer. What like terms do I have here? Yeah, the squares and the x's. Yeah, good. Minus 45x, and there you go. Cool. All right. How do you feel about that? And guess what? Saves your ass the same as always. What always saves your ass? PEMDAS. Please excuse my dumbass son or Janet's out, whichever one you can remember better. All right. And real quick, I want to make sure you guys all see this. This Wednesday, there will be a quiz on Chapter 5. Last Wednesday, we finished Chapter 5, so this Wednesday, we should be ready for the quiz.
Do you have a practice test for us?
It's just a quiz. I never have a practice quiz for that. Okay. Never have practice quizzes. I have practice tests. This is just a quiz. It's going to be very basic.
Have you passed out the practice test yet?
No. The next test is not till the 14th, if I remember correctly. Let's see. There it is.
I think we're the 16th.
14th, yeah.
The 14th or 16th?
Yeah. So if you guys, I had a outline update a while back. So anybody not get that timeline update? Anyone? No, you're good. How do you mean? No. You're getting all excited. No, it's just because I gave that test.
Monday, final exam.
Yeah.
December 12th. That's when the semester ends.
We got Thanksgiving in the middle there, so when we come back from Thanksgiving, that day will be review day, and then the next day is test.
How do they do things?
Anybody else need that update?
This
They
semester
get the whole
ends.
week.
No, December 12th is the first day of finals, yeah. First day of finals. All right, guys, so we are getting into chapter 6, which is arguably one of the most important chapters in the book because, for example, anybody here know they're going to have to take Math 178? Like, are you looking ahead? If you're a business major, you might have to take this. And it's actually what's called business calculus. But to be honest with you, students don't have a really easy time with the calculus. It's the factoring that kills them. They forget their algebra. So the calculus, the first couple steps, no problem. And then they're like, oh, nah. Okay. So we're going to start talking about all the different methods today. And then next time I'm going to have, like I said, my attempt at a color-coded kind of outline of the different factoring methods and when to do which. Because that's the hardest question is when the hell do I do what? So let me start us off by giving us a little motivation going the other way. So chapter 6 factoring is all about pulling apart what somebody else multiplied, right? So for example, let me take us all back quite a ways. How could you factor 18 all the way? I like it. So you start to make your prime tree, your prime factorization tree?
2 and 9.
I like it. So I got two different things already. So you could do 2 times 9. You could do 6 times 3, right? But it's going to have to end up at the same spot. It's the same number. It better have the same thing that when you break it down, it better be the same thing. Because here 2 is prime, but what's 9?
3
So that ends up with 2 times 3 times 3, which you can write a little better as 2 times 3 squared. I love it. I'm trying to do charades. Now over here, same thing. 6 is 2 times 3, so you still end up with 2 times 3 times 3, 2 times 3 squared. I like it. So that certainly should sound very familiar. So factoring is the opposite of multiplying. Factoring is actually the opposite of when I say simplify. Simplify means do the operations. Factor means undo the multiplication. Jeff?
We have to do those, when you say factor all the way, you have to do it all the way to factor.
Exactly. If I say factor 18, 2 times 9 is sort of okay because I didn't say factor it all the way. If I say factor 18 all the way, which is really what's assumed here, you got to factor this all the way out. You better not stop here because 9 can go further.
No, but why did you do it twice?
Just because I had 2 different people tell me 2 different ways to start it.
You don't have to do it both ways.
You don't have to do it both. I'm sorry. Yeah, you don't have to do it both ways. It's just that this way works and that way better work too. You got to end up at the same spot. So a little motivation because now that we're in pure old algebra, we're going to start doing things, not numbers. We're going to use numbers we don't know yet. We're going to have variables, and we have to do the same thing. We have to pull them apart somehow, right? So, a little motivation. I'm going to try to do this for every factoring method, show you where something comes from so you can see how to do it backwards, right? What do you get when you multiply that out?
X squared plus X.
So, you multiply, you distribute that through, you get x squared plus 3x. So isn't it correct to say, what do they both definitely have? Since I gave it to both of them. They both have an x. In fact, I don't really need to have it there. Can't you just see? Can you see what they have in common? What do they both have in common? X. He's got 2 of them, he's only got 1. So really, when you start thinking about factoring, you're going to try to pull something back out. Like we did here. We pulled a 2 out and it was left with a 9. We try to pull stuff out of it. I can't possibly pull 2 x's out of here because what's he going to do? He's going to freak. Because he's only got how many x's to give me?
Just 1.
Just 1. So you identify what they both have and you write it down.
Okay.
So they both have an x. Now if you take an x out of here, how many x's are left? And it's beautiful the way this works. There's 2 x's there. I took 1 out, so there's 1 left. x. Plus, when you take an x out of here, of course, just left with the 3. And of course, that's what I had to begin with. Bless you. Anybody know what this kind of factoring is called? I actually call it undistributing before we talk about factoring because I don't want to freak people out. It is undistributing, isn't it? It's like distribution in reverse. Here you go. No, give it back to me. All right. So, but this is really called GCF. Exactly. Greatest common factor. The biggest thing I can take out of both things. So just to show an example of what is called greatest common factor. It's almost like lowest common denominator. Right? There are common denominators, but there's one lowest common denominator, the smallest number you can use. This is the biggest thing you can take out of everybody. So what do you think if I write this here? And the instructions here would say factor.
Just what?
Yeah, what number do they both have?
Y.
That's interesting. I like that. That's cool. All right, let me catch up to you. You guys are thinking you have ESP. You're thinking that the letter they both have is Y. I agree with you. But if I just take a Y out, I didn't take out the GCF. I didn't take out the most I could. Because they both have a 2. Exactly. Do you see that? So it is just like that. You can take it numbers and then letters as they come and see how many you can take out of each. And you just kind of collect it over here. I can take a Y out. I can take a 2 out. Now, one little thing I'm doing that I really want to make sure you guys understand, put that off a little bit. Put that off to the side a little bit, because very often what will happen is somebody will put the 2y here, and then they'll say, okay, that's -2, yay, and they forgot what for that guy. They forgot that guy totally. That kind of sucks. So when you figure out what they both have, put it a little bit over here, and now write directly underneath him what's left. He had a 2, took it. He had 2 y's, I took 1, he's got 1 left. Do you guys see that little quick conversation you can have with yourself? What the hell's left? I took this is what's left. He had a 4, divided out of 2, so he's got a 2 left. And he had a y, and I took it. How do you check yourself? Yeah, multiply it back out and see if you get back to where you were. So you can always check these. I love it. Our tutors are cool dudes, but it's still weird if you watch and you teach. Because I have to do that for other people too. We all have to evaluate each other, all the teachers. And we have to turn that in, and say what sucked and what was okay, what to do better. I'm sure he's going to say, Jeff, you might want to write in English. I don't know what language you're writing in. So what about this one here? Let me try one just a little more involved here. Remember, you break it down into its parts. You do the numbers first and then do the letters. So the 4 can definitely come out of both, right? Can't take an 8 out because he'd freak. How many x's can I take out? Why? He's got 2, but he's only got 1. So the really cool, quick thing with variables, the smallest exponent one is the one you take out. So there's a 2, there's a 1, I can take an x to the first out. If I try to take x squared out, he would freak. He's only got the 1. Right? So you take 1x out, and then how many a's can you take out? Yeah, the smallest variable, smallest exponent is 2, so I can take out a squared. So he had a 4, I took it. He had 2 x's, I took them. I took 1, so how many x's are left? He had 3 a's, I took 2 of them, so he's got 11.
Aren't there kind of or 2 x's left?
He had 2 x's, right?
Right.
How many did I take?
1.
So how many can be left?
But that 8 still has 1.
But he's his own term. Do you see what I'm saying? There's this term here. So what's left from this term is going to go here, plus what's left from this term is going to go there. Do you see that? If I have a start with 2 terms, I better end with 2 terms, right? How we doing? A little bit, maybe? Not really? So what about this guy? He had 8, divided a 4 out, so I'm left with 2.
Oh, no.
Are you divided?
Totally. What do you do when you distribute? What operation do you actually do? Multiply. So when I undo it, I'm dividing. In fact, think about it like this. What number do I have to put here so that when I distribute a 4 to it, I get 8? 2. So divide a 4 out of 8, you're left with 2. I had 1x.
It's gone.
They took it. I had 2 a's.
One.
Took it.
Oh, it's gone.
Yeah, both my a's are gone, right? How do you know you're done? They have nothing in common. Be careful. You can distribute to make sure that you've done right so far, but I know I'm done because they have nothing left in common anymore. I know I took out enough stuff.
So wait, so if we get to that step and there's stuff in common.
Yeah, exactly. Now watch. Let me do that same problem again, but I don't make a mistake. And it won't be a big mistake. I can correct it very easily. So the same problem again. What's that? Sorry, Rob.
How do you get there, 2?
Here?
Yeah.
One thing is, 4 times what is 8? 4 times 2 is 8. So it has to be a 2 there. So when I distribute the 4, I get 8. The other thing is, when I distribute, I multiply. So when I undistribute, when I take it out, I must do the opposite. I must divide. What's 8 divided by the 4 I took out? 2. And think about it. What's a cubed divided by a squared? A to the first. Right? I am dividing it out. Because I multiply when I put it in, I divide when I take it out. That's how math works. It's got to do the opposite, right? So here's the same problem again, but I'll make a little mistake. And that's the kind of mistake I like to make in here, is when I announce that I'm going to do it. So let me actually make a couple mistakes. Let's say I take a 2 out, because they both have a 2, don't they? I'm wrong because I haven't taken enough. And let's take an X and an A. How we doing? I can do this. I can take that out, but it won't be right. It won't be completely factored. So what am I left with here?
X.
4 divided by 2 is 2. I had 2 X's. I took 1, so I have. And I had 3 A's. I took 1. 8 divided by 2, 4. The X is taken out, right? I had 2 A's, I took 1, so I have. Now see how you can see they both have stuff still?
Yeah.
They both have an A, at least one A, and they both have a 2. So to correct this, I can take out an additional 2.
Take out all that.
2 times 2 is 4. You guys kind of with me on this? If I take another 2 out of here, isn't that going to come out here, make that 4? And what else can I still take out? An A. So if I take an A out of here, A times A is A squared. So 2, I took a 2 out and an A out, so I get XA. And I took a 2 out of here, so I get 2, and I took that A out, I get the same answer I got before. I would not recommend doing that on purpose, because it gets a little ugly from this step to this step. But if you notice there's still stuff that is common, just go back and do it again and just take out more of that stuff. It makes it a little bit quicker. Good. Oh.
Can you take out a 4 in that? No,
Take it a 4.
at the very beginning. No.
That's what I did there, right?
Oh, yeah.
So again, this is the same problem. I just did it a little wrong to begin with. I made a mistake. I didn't take out enough. But it's telling me, hey, you didn't take out enough stuff. We both still have an A. We both still have a 2, right? How we doing? Okay. So some of you guys, I know this is old stuff. You're really good at this. I love it. Some of you guys, it's been a while or whatever. Right, so you got to remember this stuff. All right, what about this? Let me give you a little challenge. Your thought process does not change at all. Besides, it normally starts with a, oh shit. But I added one more term than we've been doing. Who cares? It's still the same thought process. I added one more variable than we've been doing. Who cares? It's still the same thought process. You do it one thing at a time. What's the biggest number I can take out of all three of those?
4.
Careful.
2.
Can I take a 4 out of 10?
Nope.
So that's a good place to start. You say to yourself, okay, 4 works here, but not there. 2, because they're all even, right? So it's got to be able to come out of all of the pieces.
So the negative doesn't matter then?
Negative doesn't matter. It's just going to be a minus inside once I take it out. Yeah, good. So I can definitely take a 2 out of all three of those, right? How about how many A's can come out?
3.
Now see how the variables are quick. I don't care how many I write down there. Who cares? You just look for the smallest power.
Okay.
3 A's can come out of all of them. How many B's? 1.
1.
And how many W's? 2.
2.
And try to finish that out. See now, if you move that over a little bit, you can just drop the answer right below what it used to be. It makes it a lot easier to see what the hell's going on. So 16 divided by 2 is 8. I had 4 A's, took 3, so I got 1 left. I had 2 B's, I took 1. 1 left. I had 10 W's, so I took 2. 8. So you see how it doesn't really matter how big I make the exponents. Who cares? You know, I had this many, I took this many, I had this many left. You know, that kind of math is nice, right? Just straight up counting.
Negative 2.
Good. So minus 2.
8, 5.
Yeah, had 8, took 3, got 5. Had 1, took 1.
Gone.
Had 2, took 2.
Plus 5.
Plus, yeah,
5.
5.
That's it.
Took the 3 A's, took the 1 B, took the 2 W's,
That's
left
it.
that dude with nothing. And how do I know I'm done?
We
Obviously no variables come out because he's got no variables, right? So you can't give any more. And no numbers come out because 5 doesn't have anything in common with 2 and 8. Alright, cool.
It's not that bad actually.
No, it's not. So, here's the next level.
Right? It's gonna have to say that, right?
Oh yeah.
So GCF should be the thank God problem. It should be really easy. Alright, so here's the next level. What do you guys think about this here? Let's see.
I don't like it.
You don't like my tone with that. Okay. Let me ask you this question first, because this is a really difficult question. How many terms are there?
2.
2. I like it. There are 2 terms. Because what is x minus 1? It's one number that I don't know. So there's a term here plus another term there. What factor does each term have in common?
X and 1.
So let me ask this too. Does anybody have an x up there? The correct answer is no. Nobody up there has an x. They both have a x minus 1, right? It's sort of like, does 40 have a 7 in it? When I say it like that, you know what I mean. I mean, does 7 go into 40, right? But 40 is 8 times 5, right? And isn't 8 7 plus 1? Now, why is that stupid, what I've just said? It still doesn't have a 7 in it, because when I say has something in it, I mean does something multiply as a part of it. 7 adds to be a part of it, right? It doesn't multiply to be part of it. 8 and 5, or you break the 8 down into 2, 2, 2, but still, those are parts of 40. So here they both have an x minus 1. So what can you take out?
X minus 1.
X minus 1. And what's left? 2 plus a. Not 2a, be careful. I'm not multiplying all of a sudden, I'm still adding. Let's check it. We're not used to doing this, but I can certainly do this. X minus 1 times 2 is there. X minus 1 times A is there. Hey, it works. You guys kind of with me here? So a little side note. What's 2y plus ay? What comes out of there? Y. Why? Because there's a y here and a y there.
That's the one thing there.
So you take a y out, and what's left? 2 plus a. Now some of you guys noticed it's the same stupid problem, right? So instead of y, I have x minus 1. Do I know what either one of them is? No, I have no idea what the hell y is. I have no idea what the hell x minus 1 is. But don't these both have an x minus 1 in the same way that these both had a y? The parentheses make it one thing, so I can take that whole damn thing out. And you have to understand that to be able to do the next level of factoring, which is called grouping. Some of you guys might remember that. That's actually like the last step on grouping. Okay, some of you guys look very excited about this whole thing. Hopefully, it's because this is all old news to you.
Old but new.
Hopefully. I don't want to think about it.
That'd be a terrible day.
It'd be nice if Phil Rivers showed up there.
Oh, I know, right?
That would be nice. Anyway.
Seriously.
So here's grouping. Okay. First thing I want you to notice is how many terms are there. Careful now, don't overthink it. There are 4 terms, right? 1, 2, 3, 4 terms. So you do grouping when you have 4 or more terms. You do grouping. And that's part of what I do for you for the handout that I'm going to give you on Wednesday. I actually write down, when you have 4 terms, what do you do? When you have 3 terms, what do you do? When you have 2 terms, what do you do?
And we can use that on the test, right?
No. You can use it on homework, though. And that laugh is a little hollow. But it's kind of funny when a problem that you get, it actually tells you what to do to it. So this problem is telling you to do grouping. And what do I mean by that? Is there anything that comes out of all 4 things? Do they have anything in common, all of them? No. Not a damn thing. He's got a 4 and a y. He's got an x squared right there. It's screwed. It doesn't have anything in common. But if you group them, I'm going to try to break the habit of some of you guys, if you put parentheses. Have you done grouping before? Do you put parentheses around it? I always say don't do that because if there's a minus, it'll mess you up. Just underline it. Here's one group, there's the other group. What comes out of this group? Good, because this little group by itself definitely has an x in common for both terms, right? So if I take an x out, what's left?
X4.
X minus 4.
Beautiful. Plus,
Y.
yeah, a y comes out.
Yeah.
X
And what's
minus
left?
4.
X minus 1.
Now, if you don't get the same thing here and here, you either made a mistake or it's not factorable. Because the next step depends on these being the same, right?
Right.
What can I do now since these are the same? What can I take out of both? I can take this whole thing out, right? They both have one of these. And what am I left with? X plus y. You can just cover what you just took out. It's silly. So x plus y. That's grouping. And you do it, you know when to do it because the number of terms tells you when to do it. If you have 4 or more, I can have 6 terms up there. You just make 1, 2, 3 little groups.
What about 5?
5 gets a little more interesting. There are forms of grouping that rely on some of the more complicated forms of factoring. So we're going to come back to some of the harder grouping problems once we learn some of the other factoring methods.
Is that a Y in the second?
It's trying to be a y, yeah. Because there's a y here, yeah.
Oh, whoops.
So you're really not using the number y, the number 4 and the letter y in the same problem. Yeah.
Let's say you have a question on the quiz, you're gonna mention is grouping or the ECF.
No, I'm not going to say that. That's why I try to teach you what it is about the problem that tells you what to do, right? Because the biggest mistake I see people make is they try to attack a problem using the wrong method from the beginning. It ain't never going to work.
So there's 4 terms.
Where are we at? Got the what? Okay. Can you make it a more specific question? So in the first place, is there any like terms up there? Any like terms? Right, there's no more x squares. There's no more just x's.
Yeah, I see how you got the second.
The second row is good,
Yeah, I
right?
know that.
All right. What is this and this? What do they both have in common? That's the GCF then. The thing that they have in common, that's the second word in this phrase, right? Greatest common factor. So that's the thing they have in common. So it must have been given to both of them. So let me ungive it to them, right? Do you see that? So sometimes some of these are a click moment. I've got to wait for it to click. But I just took this back. They both have it, so give it to me. And now the poor little X dude's by himself, the poor little Y dude's by himself now because I took that thing away from them. Evil Jeff. All right. Yeah. I can make variables cry, so don't mess with me. Okay. Cool. So let me try something just a little bit more difficult here. If you can say there's a nice thing about these kind of problems, it's the fact that you're not totally by yourself and you're trying to figure out what to do. How many terms are there?
4.
So I know I can do grouping. So I group them up. What can come out of these two here?
M2.
Good. So 4 and an m squared. Can any p's come out?
No.
Nope. And then what are you left with?
4.
Good. 4m. I had 3. I took 2. I have 1 left. Minus. I like it. The 4's gone. The 2 m's are gone. You're just left with a p squared. Now here's where you got to be careful. You got to be careful. 15th puberty. If you take out of this next one, what do you know has got to be left over in this next one?
Same
Yeah, that's an awesome thing. Once you get the first part done, it's telling the problem is saying, dude, hey, you better have this here or else you're screwing up, right?
So grouping, you always have to.
I have to have this and this be the same, or else how could I ever do the next step? And that's a mistake I see people doing. If they have a plus sign there, they somehow do the next step. They just put them all down there, like, please, no. Because the only way to do the next step is to have the same thing in both so you can take it out. If they're not the same, you're screwed up or it's not factored, right? So I know I want to have this here, but what can I take out of both? If I take a p out, what's left here?
4.
Is that the same as that?
Yeah.
Is it? No. You just said negative 4m. It's supposed to be positive 4m. So what kind of p should I take out then to make the signs right? Negative p. Cool.
You just carry that sign down.
Just put the minus.
Yeah, basically that if that's a minus, you pretty much always take out a negative there. And just to double check, you just make sure you're getting this, right? So now if I take a negative p out, I'm left with positive 4m. P cubed divided by negative p is minus p squared. So now I do have the same thing in both. That's exciting, Jeff.
So yeah, like what you just said, like so if it's a minus, I can always just bring the sign down and be right.
Yeah, pretty much when there's a minus in the middle, you do want to take that down. There are some harder problems where you actually, depending on what this guy is, you might want to leave the negative inside.